Dear audience, hello and a very good morning to all of you. I welcome you all on behalf of SARC Energy Center. Thank you for joining us today for the webinar on use of covered conductors in medium voltage power transmission. My name is Mehnaz Khurshid Gardezi and I am working as communication specialist at SARC Energy Center, Islamabad. I am grateful to our panelists for today. We shall be joined by experts from US-Pakistan Center for Advanced Studies in Energy, National University of Science and Technology, Pakistan, and Acsr Industries Limited, India. Dear audience, before proceeding with the agenda, I would like to draw your attention towards some important points related to today's session. Please note that today's agenda of this webinar is already available on SEC website, and you can also access it through GoToWebinar panel on your screen in handout section. All presentation and its recording links will also be available and uploaded on SEC website. There will be a brief question and answer session after each presentation. Participants will have the opportunity to ask questions to our presenters by typing your questions under the question tab on GoToWebinar panel on your screens. You may send in your questions at any time during the presentations. We shall be asking questions on your behalf. Due to time limitation, we apologize in advance if we are unable to address your questions. Dear audience, please connect with us through our social media channels to remain updated about our upcoming programs and events. Our social media handles are displayed on the screen for your ease. Dear audience, I shall now invite Mr. Ahmed Tala, who is working as Research Fellow Technology Transfer at SARC Energy Center. I would like to request him to take us through the technical session of this webinar. With this, I would like to thank you all. Over to Mr. Ahmed Tala.
Thank you, Ms. Mehnaz, for the introduction. Dear audience, my name is Ahmed Talha, and I'm working as a Research Fellow Technology Transfer for the SARC Energy Center. We shall now welcome Dr. Syed Ali Abbas Kazmi for the first session today. He's working in US-Pakistan Center for Advanced Studies in Energy, National University of Science and Technology as an assistant professor. He received PhD degree in electrical power engineering from Sungkyun Kwan University, South Korea. He is currently an assistant professor with the electrical engineering department in National University, Pakistan. His research interests include power stability studies, distributed generation, smart distribution networks, power system optimization, power system planning, and scheduling. Welcome, Dr. Ali, to this webinar. Thank you for joining us. Let me make you a presenter so you can share your screen. Yeah, we can see your screen. Please begin. Can you please make it full screen and then please begin your presentation?
Yes, I'm audible. Thank you, Tala. Thank you, ma'am, for providing such a great opportunity. So let's start with the presentation without any further delay. So today's topic is use of covered conductors in medium voltage power transmission systems. So here's a little bit brief about myself that has been briefed also by the Talha. So I will quickly go through the contents of this presentation. It will start with introduction with types of conductors, and later on the problem formulation and on-ground impact at glance. So to start with introduction right away, I would like to cruise you through a little bit history of this power system, especially conductors, that they had a phenomenal role in war of currents and the very system we have today in terms of AC system. So also due to large covering electricity power across a large geographical distance, they made it possible. So as the time proceeds, the today's power system, which is hierarchical arrangement of generation, transmission, distribution, and utilization, we are progressing towards the future power system. And that power system also includes a smart grid. Smart grid is intelligent grid. And this is a vision of till 2030. And after that, there will be super grid. So to achieve all those feats, each segment of those this grid system matters. And today we're gonna just discuss one segment, that is conductors. So quickly going through the types of conductors. So they are basically classified in terms of three main types. One is bare conductor or overhead conductor that we have usually at in our service. The second one is underground cable, and the third one, the very one we are basically talking about, is covered conductor. Uh, Covered conductor, as we all can perceive, that it must have been covered with some kind of insulation. So first of all, I would like to go through the bare conductors. What are they? So the medium voltage system that we have today at our disposal mostly use this bare conductor or uninsulated conductors. They have attributed to various benefits, which includes easy installation and economical maintenance. And in comparison, they have low economic burden in terms of life cycle cost and other things, internal rate of return at present value, BCR, comparatively. And also the models have been very much developed for this system because of its extension installation. So they can easily loop between poles and are composed of various material depending upon the economical scenario. You can use whether copper or any other kind of conductor as the application demands. So overhead conductor in nature, they resides in roadside poles. The collective assembly of whole provides a suitable ground clearance for the conductor, so that there must not be any danger uh, to the surrounding vicinity. However, there are certain problems or risks to which they are susceptible, like risk of failure, and may have impact on environmental vicinity. So the bare conductors, if they fall within the contact distance of immediate underground, it can be due to vegetation, it can be due to any uh, direct contact with any kind of vehicle, or any kind of thing that may have been possible. That problem lies here. So now, when, for example, by any means they fall down, they provide a grounding path, and they can cause electrocution of immediate people or life around that. It can damage the conductor if it falls through arcing, and also cause fire. So, the bare conductor, for falling bare conductors, uh, tree branches may provide high resistance, a path that may not operate protection devices. That's the first very problem, because most of the protection, that is overcurrent protection, it might not have its potential threshold to which it gets operated. And however, the low current, if there is some low current, it can cause conductor fibers to ignite and fall down on ground, thus start fire and causing safety issues on ground. You can see some visual illustrations of these kind of happenings. Uh, Usually, I will support it with my data that they are very much prevalent in the SAARC countries, particularly in Pakistan. So the possible uh, solution for that problem is covered conductor system for distribution, especially the medium voltage distribution. So then I'll move to the underground cable, because we are just going through the classifications of all those conductors, so the listeners or the participants can have a good know-how about what their types and classifications and backgrounds are. So the underground cables or conductors are used for power application where it is impractical, difficult, or dangerous to use overhead lines. So they are widely used in densely populated urban areas, or in factories, or even they supply power from overhead posts to the consumer premises. So usefulness of using underground cable is because they are suitable for congested urban areas with installation issues. Because when you have to make an extension within a pre-planned area. It has certain economical and technical constraints. So we try to have a trade-off, and it lies very much within that trade-off that at a small fraction of cost you can use it in planning further extensions. So they are low maintenance, and the comparative losses or trippings are comparatively very low as compared to their overhead counterparts. And they have small voltage drop. Usually the overhead conductors that we have in use, their voltage drop may lead to 3% depending upon the length of the conductor line. However, this underground cable, their voltage drop is comparatively less. That we have checked, it was less than 1% for 1.5 to 2 kilometers. So there are fewer faults, not susceptible to shaking and shorting due to vibrations, wind, or accidents, which the overhead counterpart may be susceptible to. They are not easy to steal or make illegal connections or sabotage illegal connections like pilferage or what we call direct kunda kind of thing. So they cause no danger to wildfire or low flying objects like helicopters or drones or any kind of those flying objects. So the issues regarding to this underground cable, because science does not solve any problem unless creating 10. So the issues regarding these underground cables are that they are more expensive than overhead counterparts. It depends that it may go from 2% to 2 times to 6 times as per application to which you are basically installing them. The fault identification, sometimes it becomes challenging, and if God forbid some fault happens, it's difficult to repair the broken underground cable. So the damage to underground cable is possible in case of any construction process, and also the electrocution may occur to people if they are unaware of the underground cable existence. So for that, they usually put up some signs that there is some underground high voltage or medium voltage cables going through this point. So it's not even possible that there might be a stone over there, but what about the other length of that conductor? People may not aware of that. So these are some issues related to that as well. So now we come to the covered conductors. So the covered conductors is a trade-off between overhead bare conductors and covered underground conductors. So as per European Commission for Electro-Technical Standardization, EN 50397, which gives the limit of covered conductor up to 36 kV. As per the definition, it consists of a conductor surrounded by a covering made of insulating material as protection against the accidental contacts with other covered conductors and with grounded parts. So it comprises of single core with a variety of insulation layer and outer sheet coverings. So the covered conductors types used at the distribution voltage, usually the distribution voltage we have in Pakistan is 11 kV, which is dominant. So the cross-linked polyethylene and high-density polyethylene, these two are basically mostly used in covered conductors. Then we have got aerial cable system and spacer cable system. Let's go through each of them one by one. So the covered conductor types at distribution voltages, it includes, the very first one is XLPE, or what we call cross-linked polyethylene and high-density polyethylene. They may be single or multiple sheeted. Most common sheet materials, they are the most common sheet materials that are in use today for that. And the conductors that are basically encapsulated by these kind of materials are copper, aluminium, and ACSR and AACSR, etc. So as you can see on your right hand side, the both XLPE or cross-linked polyethylene and high-density polyethylene conductors on your right-hand side. Then we'll just move to the next one, and you can also see that there is single sheet mostly for that matter. Now we come to the second part, that is spacer cable. Kindly refer to your right-hand side again. The spacer cable, it is a three-phase covered conductor in polymetric sport cradle. You can see the cradle over here as well, and it is supported by a messenger cable, and the spacer is on the right hand side. If you can see the spacer, that causes a typical space between this triangular arrangement of conductors So they keep them at a distance, and they also are very much they provide the mechanical strength as well, subjected to winds and other kind of calamity that may occur in the field. Then the third one is aerial cable. Kindly refer to your right hand side as well. Aerial cable is insulated three-core cable with an earth screen. It's used for both overhead and underground application. So let's go through the covered conductor type 1. So the covered conductor type 1, it's single sheet covered conductor. The characteristics of this single sheet covered conductors are that they are typical of low density XLP and covers thickness up to 3.3 millimeter till 33 kV. Just to add to this thing that that insulation has direct link with the voltage. As you increase the voltage level, the insulation gets thicker and thicker. So normal use of aluminum alloy conductor and XLP or HDPE sheets of 2.3 millimeter thickness, they can also be used. So 1.6 millimeter thick sheet for ACSR and 1.8 millimeter thick sheet for AACSR. These are the basically classifications of the thickness of this insulation that are attributed to those conductors when they are in covered conductor arrangement, single sheet. So if we use the copper, it is usually used in extremely salt polluted environment, usually in the uh, we call sea area or coastal areas. Basically, mostly we use the copper because it's extremely salt polluted environment. So HDPE sheeted conductor is used in coastal environments with less carbon percentage. It provides some resistance to the outages caused by tree and wildlife contacts. And the thinner sheet reduces the overall diameter and it leads to lower vibration level. Those vibration levels may cause a lot of difference. So you can see the single sheet covered conductor just below this description. Now we will move to the multiple sheet covered conductor, and it is also known as ABC conductor or multiple sheet conductor because it has three layers. There are two or three sheets layer at medium voltage, which ranges from 6.6 to 33 kV. The three layers whose figures are corresponding below, you can see the if you refer to the A part, the A designation, it is the semi-conducting sheet close to the metal conductor uh, to equalize out the electrical field. So above A, there is insulating polyethylene sheet that is designated as B, and above that there is a hard abrasion resistance outside layer of HDPE that is designated as C. This ABC cable is also very much in use in Karachi Electrical Supply Corporation. If I talk about Pakistan, in Baldia and Liari for theft control. Now we move to the covered conductor type 2. Now they are spacer cables, as you see in the diagram on your lower right hand side. Those spacer cables, they are arranged in phases in a polymetric sport cradle. You can see there is a messenger cable. This messenger cable above that, this one, uh, it keeps this thing in a close triangular arrangement or configuration. It provides the mechanical strength to weather or severe storms that may occur in the vicinity of those cables, and the electrical strength to prevent faults due to phase or phase to ground faults, because they are unsymmetrical faults or contact or animal contact. They provide electrical strength to prevent those faults basically, because in the this sport, the very sport, the whole this spacer kind of arrangement with the pole and all those things, it provides a very good mechanical strength to those conductors. They cannot be easily shaken basically for that matter. And also in bare conductors, if two conductors can get uh, together in terms of line to line fault or other kind of fault, those faults are usually not uh, possible because of this insulation material that is in between these two. and also the complete coordination system, including cable, messengers, spacers, insulators, and hardware, gives this whole arrangement that is shown over here. Then we move to the covered conductor type 3. So it basically encapsulates aerial cable. You can see on your right hand side and just below. So you can see that the features of this is that insulated 3-core cable with earth screen. You can see that there is earth screen cable is there as well. We also call it armor cable for some reasons as well. They are used for overhead applications as well. They can use for underground application as well. They are fully sheeted 3-core power cables, excellent contact resistance, and go overhead, underground, underwater. They have less voltage drop than single sheet uh, conductors and bare conductors. They are weather resistant aerial bundle cables and neutral conductor, which is at the disposal. So if we see a comparison of schematic reliability of conductors, so you can see that the bare wire, although it has less cost, however, it's also susceptible to a less reliability. If we see that covered conductor, its cost is comparatively high if you see towards your y-axis and then move towards the x-axis. So the reliability is somehow much greater than bare conductors. But as you move to the spacer cable and aerial cable, the other higher counterparts or what we call that covered conductor superiors for that matter, the cost get high, so is the reliability. So for that matter, this covered conductor is a sort of trade-off between these high-end counterparts and low-end bare wire, because it is at a fraction of cost, it gives much better reliability as compared to bare wire, which is basically in use today. So what are the advantages that have been attributed to those covered conductors? So the advantages include that they basically reduce the probability of electrical contact between conductors and surroundings. They reduce the overall technical losses due to direct hooking and theft. The reduction in maintenance cost is one of the very key factors, and as I will show you that when we will formulate that problem, uh, these costs that we have to bear have a tremendous impact in benefit to cost ratio basically. So the decrease in spread of hazardous non-linear electric field like EMI interference, it is reduced to very much, and it is supported by the technical figures or research figures as well. So the increase in the stability of voltage and current profiles through the distribution line is another feature related to them, and the probability of power outages is one of the very main factor that it reduced downtime to a fraction of system, and that is something that utilities are very much after. So it improves the quality of delivered power to the consumers and improves the reliability of the network operationally and economically. So just to give you a data, that monthly tripping in ISCO, that's Islamabad Electric Supply Corporation, that is a DISCO in Pakistan. As you can see that at 11 kV line, you can see the trippings in just 1 month. You can see there are plenty full of trippings. Below 20 minutes are shown over here, and above 20 minutes in a whole, they add to a very much downtime in terms of service to the consumers. And this is a quarterly report of monthly tripping is in ISCO, and especially if you see this 11 kV feeders, there is a very big amount of trippings. It may be due to any natural cause, any man-made cause, any vegetation kind of thing. Basically, these are the main factors for that. So you can see even in terms of reliability indices, the SAFI is comparatively, although it's less than 10%, is fine for certain utilities, but as per international standards, it must be further, it has to be better. And if we see about the SATI, that reliability index, it's 74. It must be above 80 or 85%, which is 74.21 with these overhead conductors. So also in terms of fatal accidents that has been occurred due to this bare conductors. You can see these are basically the, if you see on the upper left hand side, these are the discos in Pakistan, which have these accidents across various years. You can see this that this public safety and other thing, it's a serious question mark for that matter. And we have taken this these figures from NAPRA State of Industry Report 2009. Also, the SEFI ISCO didn't share the data, so that's why I shared that data before this chart over here. So as compared to the others, that SEPCO and MEPCO, they have very high SEFI issues in terms of reliability. Now the problem formulation. As far as problem formulation is concerned, the main problem with the system is, no matter how good your system technically is, if it's not economically viable, it doesn't have any means to be implemented. So to find out the problem formulation, for the researchers or even the experts, so the main problem formulation of a covered conductor utilization usually aims at reduction of the associated costs. Now we would like to see what are those costs, and also the additional cost of operation, damages, and poor quality of the delivered energy to the consumer needs to be strongly decreased, because if it has to be decreased, then we can move towards a smart grid, or the it's a prerequisite for that system that we are ultimately aiming for. And the transmission system will not afford any external costs that are associated with it, because the actual basket price of the electricity that we basically consider, so 2/3 of associated cost with the distribution basically rests with the distribution, and 1/3 with the transmission. So the external cost is something that has to be minimized. So the cost of maintenance vehicles that are utilized to solve very dangerous faults, that's the first one. Cost of planes that are utilized to make difficult repairs. Wages of the excessive labor to work in extreme climate conditions with more time wastage. And also great savings in money can be achieved that will increase the reliability and enhance the economics of MV transmission system that utilize covered conductors. So the problem formulation, if we move towards that, the methodology to calculate the total cost of medium transmission system that utilizes covered conductors is, uh, now to address that, I would like to go towards the law of Kelvin procedures that states that the total cost of transmission system is divided into two major categories. The very first variant is shown in equation 1 with possible addition of other costs. The second variant is shown in equation 2. Now the first one involves with the capital cost that are independent of cross-sectional areas of the utilized CZ covered conductor cables or any other elements of the network. And the second involves the costs that are directly associated with the cross-sectional area of the utilized covered conductors. You can see now here, if you see that the total cost in the first variant of problem formulation, we don't consider this cross-sectional area. It seems to be very unrealistic if you don't consider that, for that matter. And it only includes the total capital cost and other costs that are related to CSA. Basically, you just split it as another thing. In addition to that, now in the second contingent or second variant of this problem formulation, we have initial fixed cost that involves the cost of outages or faults. The CR is total running and operation cost, and also N is the total lifetime of a system that is that utilizes CC. It includes the life basically the time of life cycle cost, life cycle basically, that for which is system would have been installed. Now, if we talk about the problem formulation and considering the second variant of Kelvin's law, the technical parameters that includes are conductor type, maximum load current, respective length of the cable. When we move to the cost estimation parameters, we have capital cost that includes purchasing cost of cables, accessories, design, installation, and civil works, followed by the second one, cost, other cost, which includes contingency, including faults and miscellaneous costs. And the third one is cost estimation, running and maintenance cost, which will occur per year across the whole life cycle cost of that system. Now we move to the on-ground impact at a glance. Although in the SAARC region, India spearheads the technology in terms of this covered conductors. However, even in Pakistan, we have this scope of installation at two levels. One is low tension service main, that is up to 440 volt, and the second is 11 kV MV feeder, medium voltage feeder. Now we implement, as we see on ground, there are, just give me a moment. On ground, low tension covered conductors are installed in two subdivisions of MEPCO. Number one is Multan Circle City subdivision, and second one is DG Khan Circle. And implemented at both low tension and medium voltage in K Electric in under the project named Project Ujala. So KESC aerial cable ABC type of covered conductor project, Project Ajala, that was around 150 million USD. And EEC was the EPC contractor that executed the project. So the K Electric implemented this project at the following locations, namely Gulshan Iqbal, Bhitai Colony, Liaquat Market in Malir, PKT Colony at Defense, Naval Colony at Baldia. The immediate effect of these covered conductors is this, that in Gulshan Iqbal alone, losses drastically reduced to 80% of its initial value, and 90% area was exempted by load shedding, because as per one of directives from the Supreme Court, that if any feeder is the revenue from any feeder is less than 50% due to pilferage or other losses, it can be cut off from the system, as an example, to recover the rest of the system. So when the losses was drastically reduced to 80%, and the 90% area gets the immediate effect that they were exempted, because mostly the pilferages or technical losses were reduced to a very small amount. And the puncturing of ABC cables is extremely difficult, and direct hooking was reduced to zero. That's the immediate effect. As you can see, the link is given also in this uh, in these images, in which the K Electric engaged the local community and converted the area into ABC aerial cables. And people are very much enthusiastic, and they just request to install that whole system across the whole area. And also you can see in certain places where the distribution, in distribution, they basically from the transformer to, in the first phase, from the transformer to the service main and onwards, the covered conductors are basically used, and it has been totally revamped. The system is has almost revamped in terms of practical on-ground installation as far as covered conductor cable is concerned. So these are the references that I have consulted in making this presentation, and I once again I'm grateful to the SAR to providing me this great opportunity, and I'm really honored. And the forum is open for the discussion. Thank you very much from my end. Thank you very much.
Thank you, Dr. Ali, for this detailed presentation. I'm sure this has provided a good background on the covered conductors for our audience. So we have received a few questions from the audience that we'd like to take now. So the first question is from Mr. Amal Nawaz. He's listening us from Dubai. He's asking, what is the difference between ACSR and AASCR conductors?
Difference between
ASCR and AASCR.
Wait a second, G. ACSR is wait a second. Where is this thing? I've written it over here. By that time, there is any other question, I will give its answer a little bit later. If there is some other question, I will take this by that time.
The second question is, can we use ACSR for medium voltage level transmission as well?
Yes, we can use it. Yes, we can.
Okay.
Say it again. Wait, say it again. Sorry, I didn't got that question.
No, but this was a question that can we use ACSR conductor for the medium level voltage as well?
Yes, we can use. We can use. Usually they are used for 132 and other kind of thing, but we have to see the C mill and other small variant. We can use. Yes. Any other question?
Okay. The next question is also, what is the main function of armored cable? If you can just explain.
Okay, the main function of armored cable, basically, when we are working with, especially I would like to give it, I will explain it by example that in a factory area where we use underground cable and it's usually armored cable, and basically it goes to the cable seller, and the main function of this cable is that sometimes the cable sellers may subjected to some water rise as well due to unforeseen reasons. So it must not get into the water must not get into the cable. That's the first thing. Second thing is it must not be punctured, or any mechanical problem may not occur. So that is these are a few main things regarding armor cables that we have at our disposal. However, we can also there are plentiful of applications if we see in terms of especially those machineries. We use the armor cable for those machineries for which the dead band is comparatively very low, like VFD drives or these kind of things. They basically use very specialized armor cables for operation, because a little bit frequency variation or voltage variation can cause a big trouble for them. If we just use induction motors, whether they're water starter or other kind of thing, uh, its dead band can be up to 6%. So armor cable provides a little bit better opportunity in terms of power flows and considered subjected to those kind of problems that we can occur. The main example for that is what we basically use in very cement factories, which also have heavy machinery along with the basic recovery power plant. So these are some things that for which we use the armored cable mostly.
Okay. The next question is, what about the corona effect of the covered conductors? If you can throw some light on the corona effect.
uh, corona effect of the covered conductors. Yes. Corona effect, we all are quite that corona basically this subjected to those skin effects or other things. But if we have, it also depends on the conductor which is in this insulation. If the strands are properly designed in terms of one guy just who has just used that ACSR cable, if you use it. So if the power flows and current flows through the whole strands of the conductors, then there is no skin or corona effect for that matters. As far as covered conductor is concerned, the corona is comparatively low till if I talk about ACSR conductors. By Murtaza, there is an Irani scientist who's working on that. Murtaza, he says that corona impact is comparatively less. I would like to share this reference with you as well by the end of presentation. So one guy asked, what is the difference between ACSR and AACSR? So ACSR, we all are very much aware of this, that it's alloy conductor steel reinforced, and AACSR is aluminum alloy conductor steel reinforced. So these are the two basically. This is a there is just difference of what we say abbreviations, and the aluminum alloy is something that is used at the center of this system. So this is the difference. Any other question?
And that will be all from our end. So thank you for joining us today, Dr. Ali, and we'd like to move on to the next session. So, dear audience, I would now like to invite Mr. Manish Patel from Apar Industries Limited, New Delhi, India. Mr. Manish is working as General Manager Business Development with Apar Industries, formerly Uniflex Cables, and focusing on establishing new technologies in electrical utilities, IPPs, and contracting sector. Previously, Mr. Manish has served in senior management roles, managing cross-functional initiatives with the technology and marketing domain, covering global sales, international market, business development, strategic roles with G&W Electric Company USA, Cable Corporation of India, and AppLab Limited. He has experience in EHV cable and EHV cable accessories, low tension and high tension elastometric cables, covered conductors, medium voltage switchgear, and underground distribution systems in India and worldwide. Welcome, Mr. Manish. Thank you for joining us. The floor is yours. We can see your screen. Please go ahead.
Yeah, thank you very much for giving me this opportunity on the SARC platform to talk about the covered conductors. And I really appreciate Mr. Abbas Kazmi for giving us a very good insight over the covered conductors. So I will take it a little further on the covered conductors technically and practical aspects of the covered conductors. And you are able to see my presentation screen?
We can see your screen. The presentation is not open, I think. Yeah.
Is it there now?
Yeah. We can. Please.
Okay.
Perfect. Thank you.
So, first of all, thank you, everybody. And I'll little bit give my introduction that I'm working with the power industry, which are one of the very oldest industries in cable and conductor and oil manufacturing. And it is around group of $1 billion. And we have the specific divisions for the specialty oils where we stood world ranking 3 in the production, and in the conductors we also have the world ranking for giving the lot of conductors to around the country. Over 100 countries we are exporting the conductors. Then our cable division, where mainly we are working with the fiber optic cable, elastomeric cables, light duty cables. Then we also have the e-beam facilities. So these are our small introduction where we are very prominent, and we are the pioneer one who bring the covered conductors concept in India. And now it becomes very popular. And through the Indian perspective, I'll give my entire presentation. So first of all, what we need to see that what is the fact? So in the India, the electrocution kills nearly 30 Indians a day. That's a very high figure. So these are some of the very shocking figures. And if you see the problem areas, we keep on hearing on the newspapers that even there is a electrocution which takes the human life, which takes the wildlife, like the elephants are getting electrocuted, the big birds like flamingos, peacocks, they are getting electrocuted, the monkeys, they are also get electrocuted. And this is a big problem out of that our bare lines are not providing the proper safety to all these things, and these accidents keep on happening. So it's a small thing. If you see the bare line is going on, and if some tree is there, so what happened? How this, the current gave a havoc, and it can, burn out the entire part, and it is so fatal. So you see that with the things, our electricity utilities, who are the direct users of the covered conductor, how they are, able to handle. And the major problems which they are right now you facing is the clashing of the conductors when the high winds or in the stormy season, then the conductors are loosely fitted, then they clash to each other, and then the outrages happen. Then the slashing of the conductor due to the corrosions and the other part, if some accidents happen or something, the slashing of the conductor happens. That also leads to the outrages. And the majority of the time there is a temporary tree contacts. These are the transient faults which happen and goes, but it will give an outrage because your switch gas and other things have turned off, and then you have to again rectify the line and then do the network keep on running. Then the corrosion of joints right of the way, electromagnetic field effects on the electronic surveillance. These are the something which is newly discovered, that now the lot of these security agencies, they are putting the sensitive radars at various places to get the signals, and because of these HT lines of 11 kV and 33 kV or 132 kV the going over them, the electromagnetic field effect distorts these signals and they are not getting the proper signal. So that is again a problem. And the safety is the another factor where the railroad and the river crossings are there. There is also then the emergency restoration systems. It is not in place. So these utilities are, really in a thick soup to, manage all these problems. And as Mr. Abbas Kazmi rightly said, that there is a, solutions which is coming as a, there are three solutions over the bare conductors. So how these are the, either you go for the AB cable, aerial bunch cables, or you can go the underground cables, or you can go for the covered conductors. But the problems which we have cited here with the Indian utilities, because it becomes a very popular word with the Indian utilities, that yes, the AB cable can solve these problems. But there are the problems and the challenges with the AB cable, and now this AB cable is becoming obsolete in the utilities. People don't want to, use, even if they have purchased it, it is now kept in the stores. Because they thought that this will give, if they put it on the line, that will give more problem than rather than just keep the line there. So the problems are contributing toward the smaller span, which is resulting to the increased number of poles, then the cracks on the outer surface of the ABCs, which is there, and the loose contacts, local heating, then the sheet discontinuities is also being observed. Then the copper metallic sheet sometimes get damaged because it is not properly overlapped, and during the transportation and other time during the handling at the site, this copper tapes come out, and then that creates a problem. Burn out of the sheet due to the animal bites, because the outer sheet is PVC or HDP. This is all vulnerable to the animal bites also. So squirrels and these they have a very sharp teeth, and then they create a problem in this. Then dislodging of the straight through joint, because we are using some joints over there, and if the workmanship is not good, then the dislodging of the joint also appears to that. And other than that, in the UG cable, there are the problem because it is very costly. UG cable, no doubt, is a good thing, but everywhere you cannot go for underground because of you are not getting the ROWs, and if you are getting a ROW, then also that is a very high cost. You are getting the high ROW in the urban areas or the big cities. The running, the ROW costing in like a big city here in Mumbai and Delhi is very, very high. It's more than the 2, 4, 5 times than the cost of the cable itself. So this is how it is so expensive. and then you are using the termination kits over it, then you are using, and the problem in finding out in case of any fault is there. That also a big trouble to the utilities, that finding a fault location is a big headache to the utilities. So all these things now, solved in the case of the covered conductors. So this is not a very new technology. It has been there. It is being, invented in the Scandinavian country, and they have done a lot of testings and experimental, doing the things and come out with the nicely written specs over it. And that is also, we are also following here the specs of EN standards, that is 50397 part 1, 2006. So the covered conductor construction is very simple, and if you see, there is an example, we have taken it as a ACSR conductor, where the middle strand is of steel. Then there over it, there is aluminum wires, that is the aluminum conductors. Then the red portion, what you are seeing is this being filled with the, some kind of a semiconducting gel, which prevents the water to get ingressed or the moisture to get ingressed. So it is totally a water blocked conductor. We have to make it for the covered conductor purpose. And then we have a semiconducting layer, which you can see it in the gray. Then we have a pure XLP layer, that is in the white. And then over it, there is another XLP layer. There are two layers of XLP. One is the pure XLP, and there is another black layer of XLP, which is having the UV resistance and the track resistance. These are the two important properties to keep the covered conductor on the overhead applications. So most of you have wondered why we are making the covered conductors for the watertight. So water tightness is because in the bare conductor, whenever there is rains or showers or anything happens, it gets out of the conductor because there is no covering. But here there is a covering. So what happens is, in case water get ingressed or the moisture get ingressed or water goes inside the conductor, it travels to the set point. And at the operational temperature, what happened? This water will convert it to steam and cracks the XLP and wanted to come out. So that will harm the covered conductor, and it will also reduce the life of the covered conductor. So longitudinally, watertight conductor allows the it will not allow the water to penetrate inside the conductor. So this is the very important feature of one of the feature of the covered conductor, which needs to be taken care of while choosing the covered conductors. Secondly, I said that there is a layer. There are a triple layer. It is a triple layer conductors. So the semiconducting layer. Why we are using the semiconducting layer is, you see the strands are in the form of the circular strands, or sometimes it is a trapezoidal strands are there. But wherever there are the strands, there is a irregular, electrical stresses developed over the surface. These electrical stresses harms the layer over it, that is the XLP, and it is not desirable to have these stresses in a non-uniformal way. To make them in a uniformal way, what we do is we keep the conductor covered with the semiconducting layer, which uniformly distributes all the stresses over the surface of the conductor, and it will not harm the XLP in that case. So that is the one of the reason why we put that. Then thirdly, the unique part which I have told you, that the outer layer is having the UV protection and the track resistance. So UV, you all know that XLP cannot be exposed directly to the sun. If you expose the XLP, it will crack. So UV additives has to be there on the XLP to protect it from the sun. and then it should be track resistance. Now I just go back to the construction. Here, unlike the UG cable or AB cable, basically, we don't have any earthing provision in this design. So if there is no earthing in this design, then what happens? There must be some leakage of the current over the surface. And according to the standard, this leakage of the current should be less than 1 milliamps. And once this is so that means there is some voltages are absolutely over there, and there is some leakage of current. Current is also there. So the voltage should be less than 100 volts in the 11 kV circuit network. So when when you are putting these cables on the overhead lines, you see that because of the lot of pollutants in the air, lot of dust is there in the air. So what happens? This dust particles settle down on the surfaces. Now these dust particle when settle down on the surfaces and there is a presence of the leakage current, then this current will get a path to track through. And once it is tracked through, then it will create a cracks and over the surface over a time. And if it is not track resistant, the cable, it will its life will not be more than a year. So it is an important aspect on the outer layer sheet that it should be a track resistant. And specifically in the South Asian countries and in the country like India, Pakistan, and all the other places, we all experiences a very polluted environment. So though the this EN standard is saying that it is all up to the utilities that they should decide on the 11 kV whether it should be track resistant or not. But we specifically vouch for them that on the 11 kV also in these countries, the standard should be written that utility should ask for the track resistance cable, because without track resistance it will be failed, and the life what you is desirable you will not get it. So because this systems what you are making it here is for the 30 to 40 or 50 years. It's not for the small life. We are expecting a lifespan of at least 50 years once it is properly installed at the line. Also, this covered conductors, since as I told you that it is invented there in the Scandinavian, which is a very cold countries, So their phenomena, what they are observing is every time during the snowfall, what happened? The snow loadings are there on the conductors, and on the cross arms, whenever there is a lot of snow accumulated and the short circuiting take place, the line become cold, and then once it is becoming cold, then more snow will be deposited over the surface, more snow loading is there, and because of that eventually the conductor snaps. So in some of our northern areas where the heavy snow they are experiencing, every year they have to change the bare conductors after the snow period because they get snapped down. So one of the good, because of the insulations, what happened in the covered conductor, the line will never, become cold because there is no effect of the short circuiting. Even if on the cross arms there is a lot of ice or there. So once it is not cold and the operating temperature is inside, not that much snow will be loaded over the conductors, and the conductor will serve the continuity of the electricity in the network, and you can get the power reliability of 24/7. Then the life also the conductors increases because there is no effect on the snow on that. So these are the some of the unique feature with the covered conductors, why it has been invented first and then it has been adopted throughout the globe. And we in the South Asia are the not only the people who are now looking for the covered conductor as a solution to our networks. Even in the USA, they are using the ASTM standards and they are using the spacer cables, and they come out as a Hendrix systems over there, and it has a big thickness. All the standards are more or less are the covered conductors only, but only thing the installation part, that how they are going to install it. Some are putting it on the spacers, some are putting it as a bare wire, like a bare wire in three-phase systems. So all are the same. In the Australia, you can see the AS standards, and the New Zealand also they are using it. And then in the most of the other parts, the EN standards are there. So these are the three mainly standards which are used for the covered conductors. So in India, we have adopted the technology with the EN standard, which is by the Senelec European Committee for the Electrotechnical Standardization. And these standards are so good that in one standard, what they are saying is 50397 part 1, they are talking about the insulation and the conductor part of the system. Then they have another standard like 50397 part 2, which specifically tell us about the accessories, what kind of the accessories should be used and how it has to be used. Then in the standards 50397 part 3, they are again telling us about the installation of them. So it is a foolproof, well tested from last 40-50 years throughout the globe, and many of the utilities they are only using the covered conductors rather than the bare conductors in their networks. So India is also catching up with them, and we are looking for a big future in the covered conductors. So if I can talk about the type testing requirements in the as per the 50397 part 1, it is also talking about the construction requirements of the conductor, that is the aluminum or the steel reinforced like AAAC or ACSR or AL59 or whatever you wanted to use. With the conductors of the high ampacity, you can also use in this covered conductor technology. Then the normal cross-sectional areas, they are talking about 35 square mm to 240 square mm. And they are talking about the conductor to be compacted or non-compacted, both kinds can be used. The standard conductor may be longitudinally watertight, as I told you that they said maybe watertight by means of adequate mass added to it. That is what the semiconducting gels, which is used during the stranding of the conductor to make it a foolproof watertight conductor. Then they are talking about the covering, which is basically the XLP covering, which can withstand up to 90 degrees centigrade operating. And mechanical properties, before and after AG test, elongation test, tensile strength test as per the EN 60811 part 1-2. Then physical and the chemical properties tested for the hot set test, pressure test, high temperature test, then water absorption test, then shrinkage test, and the soar hardness they are talking about. And the electrical test comprising of the high voltage test, spark test on the covering, the leakage of current, which I've already talked to you about, that there is a leakage. It should be less than 1 milliamps in case of the covered conductor as per the EN standards. And the tracking resistance test. So non-electrical test on the coverings, then mechanical property, carbon black contents, resistance of the UV rays, then test of compatibility, thermal properties of the covering, then the test on the longitudinal water tightness, slippage test. These are the tests which is commonly done in this EN standard of 50397, and this makes this technology a very foolproof technology for to be used for at least 30 to 40 years in your network, without any problem if it is properly done. So in case of the covered conductor, there is no additional maintenance is required. Only the occasional tree cutting for the maintenance of the ROW is recommended, because even if the tree branches constantly touching on the surface, that can be sorted out, but it should not be touched for a very long period. But 2-3 months it is there, it's okay. But after 2-3 months, there should be some kind of a maintenance to cut all these lines which is constantly touching the line. Then tree falling or tree branch, there's no tripping face to face or any kind of a shortage, so you don't need any reclosures or centralizers or these things, because for any 95% of the trippings happens because of the transient faults. And since these transient faults are is that like the fault comes and goes by itself, and most of the time the transient for the 95% of the faults are because of the transients, and this can be handled very perfectly with the covered conductors, so no need of any reclosures or the switches for the to get the automatically remove the faults on the line. Because even if the branch fall on the phases, or it will touch the line, there will be no interruption, it will be continued. On the event of the conductor snapping, it is very easy to rebuild the network by mid-span joints or the tension clamps. Only the two sides can be just stripped down and covered with the insulated jackets, and your network will be up around for the service. So if you see, the covered conductor has a various applications on the HVDS lines, mainly in the rural distribution lines, where they are going through the thick forest areas or through the plantation areas, and even in the many of the farms and the agricultural land, if the lines is going, the farmers objected because it will deteriorate their if it is the line is going. For example, near Maharashtra, there are a lot of mango trees are there. So if the lines is going, though, they are also deteriorating the quality of the mango, and they are not very objective highly, because they don't want any lines to be there on these trees. So these are the one of the application where you can put the covered conductors. Then in the urban areas, the thickly populated cities, the slum areas, these are the places where where the high riser buildings are violating all the ROW norms, and they come closer to the distribution lines, which is creating a lot of hazard to the human life as well as the wildlife. So these are the places where the covered conductors needs to be used. The railways, road crossings, the polluted areas, even it can be used as the jumpers, because we have seen a lot of casualties in the substation on the monkeys, big cats, even the leopards in the substation, they got died because of the open jumpers. So these jumpers, if you can use in the substation for the as a covered conductors, so then these fatalities can be reduced. Then it is also being used in the coastal areas and the highly polluted corrosion areas, industrial areas where a lot of industries are there. These are the places where you can use the covered conductors. They are the excellent application of these covered conductors in these areas, because of the salty environment, there is no effect on the conductor inside the insulation, and it is also a watertight conductor, so it can serve the whole life of 30 to 40, 50 years. Without any damaging with the corrosion or the saltiness of the water or any pollution in the networks areas. So if we can talk about the advantages, there's no interruptions by contact of the tree branches or creepers, the clearing of the lanes and growing the lanes. You know what happened many times, the utilities have to take the special permissions to cut the branches, then they have to cut the line and then prune the trees and other things. But in case of the covered conductor, you don't have to do that. While running the line, you can also do the pruning of the trees and other things on the live conditions, working conditions. No fault during the clashing of the conductors. In the case of the storms or the heavy rains, which is almost in all the south countries, they are experiencing these heavy rains and the storms condition. When the in that scenario the conductor get clashed and then again the electricity goes. So these are the situation. The covered conductor will be the excellent, solution to these type of stormy conditions. Then face-to-face conductor distance can be reduced because I am talking about right now in the Indian context. Because right now our approving authority of the CA has not come out with the clear-cut guidelines for how much face-to-face conductor distance should be reduced. But we have already tested it 50 up to 50 mm. We can do that without any problems. But still, since the government approvals are not there, so what we are keeping it on the 11 kV, we are keeping the same face-to-face distance what we are keeping it for the 11 kV or 33 kV. So we are maintaining the same, but in case of the when you are using the covered conductor, you can reduce the face-to-face distance and also face-to-earth distance. The leakage of the current, as I told you, that it should be less than 1 milliamps. When we tested the technology of 11 kV, it comes out to be 0.12 milliamps, 33 kV 0.59 milliamps, and 66 kV it is 0.80 milliamps. So it is well less within the limits, the leakage, and human heart can sustain up to 10 milliamps. So it is completely safe technology for the human beings as well as for the wildlife. But if somebody is saying that yes, whether we can touch this conductor, so we advise that you should not touch the conductor because it will give you a little a shock, a very little shock, which is not fatal for your life. But since the leakage current is over there, so you can get a little shock over there. So it should not be, and it is good also. Otherwise, if you put a covered conductor and the covered conductor is just goes in front of the balcony of somebody, then they started drying the clothes over there. So that's the good part, that it has a little bit current which is not fatal, so that people should be alarmed and they will be safe. Then to protect the big birds like peacocks, flamingos, elephants in the forest areas, ideal for the installation in the forest area and bird sanctuaries, because a lot of casualties we see in India, that a lot of elephants died and other big animals like tigers, leopards, they died because of the electrocution. Even in the sites of the renewable energy sites where the evacuation of the 33 kV is going on. So there at that places the peacocks died sometimes, and then these flamingos, these are on the migratory birds, and then it is a very heavy bird, so they can't see the bare line in the open sunlight, so they just got stuck with the open line and then they got died. So these are the sad part of it, but the casualty keep on happening when we are using the bare conductors. So if we start using the covered conductors, then it will be heavily we can save the wildlife and the human life. Better reliability under the bad conditions like heavy snowfall or windy or stormy conditions, then reduce the power interruptions and the outrages, increasing the power distribution network reliability. So a lot of nowadays the things are coming up, like in India, a lot of schemes where the central government is giving the aid to the state governments only on the basis of that if the network reliability is measurable or not. So I can proudly say that in case you are using the covered conductors, your network reliability will be very high in comparison to the bare conductors. Then, as I told you that wide right of the way can be reduced in case of this covered conductors. Then we are talking about the costing, like it can lower the cost of operations and it can also lower the cost of maintenance. If you can see the ownership and life cycle cost of the underground cable and the aerial bunch cables, the covered conductor will definitely give you a better, cheaper option against these two technologies. Sorry. Then I'd like to talk about the little bit about covered conductor accessories. What accessories are used, and the best and good part of this covered conductor is that the accessories are not far different from the what you are. Also, if there is a condition like if you want to go for a covered conductor where already there is a bare conductor in the network and you are reconductoring it with the covered conductor, you don't need to replace the poles, you don't need to replace the insulators, you don't need to replace the cross arms. On the same insulator, cross arm and poles, you can just take out the bare conductor and put the covered conductors, and it's so easy to install. Only thing we have to take care about is little bit on the covered conductor specific accessories as per the EN standard of 50397 part 2, which is the tension clamps. Tension clamps we are using there also, but here also. But only the difference in the tension clamps is that it has a polymeric gripping. You cannot allow any conductor with the XLP over it with touch with the metallic part. So the touch on the XLP outer surface should be with the polymeric gripping only. The same thing is with the on the support poles where you are using the pin insulators. Instead of using the hard wires to keep the conductor in place, here we are using the polymeric ties. Then for the suspension clamps are also there wherever the 33 kV lines in the suspended mode is there. Then another part is if this whole system is covered, then how we can take the tap off from it. So for that, there are available IPCs are there, just like the AB conductor. The IPCs are of three types. Like if you wanted to join the bare part with the covered part, there is a bare to covered IPCs, insulation facing connector. Then there are from covered to covered. If you wanted to go to take the line, there are the IPCs, which is can take you with the covered to covered part. And there is a IPC because sometimes for the maintenance, they said that it's a strict rule here in India that you have to, ground the entire system if you are doing any maintenance work on the line. So for that maintenance, you have the some earthing belts, IPCs with the earthing belts, where you can just put a earthing rod and keep the entire system grounded. Then to join the two covered conductors, we have the mid-span joints, which is very easy to install. You just have to take out the some scrap of the little bit insulation of both the side of the covered conductor, put it back there, crimp it, and just put the sleeves over it. That's all. So as I said that in the clamp side, we should not use the direct, contact of the metallic part with the covered part, because these kind of things happens if we do that. So even if we are using the wires to tie the conductor instead of the clamps, then also it will take all the insulation part along with it, and then this is a wrong practice. That is why we are using the polymeric padding on the clamps, and there is also a tracking protection to keep the entire accessory as well as the conductor on the same potential. So these all are the very easily available. Lot of companies are manufacturing these accessories nowadays, and it can be easily procured from there as per the EN standard of 50397 part 2. So you see that in case of the support poles where the pin insulators are there, we should not use like this. These are the wrong practices. There is a tracking, otherwise it will harm the entire tracking effect of the cable. You can see because of the tracking, it will spoil the entire insulation of the conductor, and you will not get the desired results in that case. Then as per the insulation pacing connectors, these are the connectors which can be used cover to cover. Then there is insulated to insulated, bare to insulated. This kinds of the IPCs are available. Then I talked about the for the earthing, you just have to put your earthing rod. So these every 1.5 kilometer or 2 kilometer you can put these IPCs so that you can take the earthing and ground the system on the maintenance. Otherwise, there is no use of it. Then, according to the utility practices and the places, you can then use these other equipments also, like the tension side with the arresters. If there is a lot of lightning problem is there, if there is a surges which is expected to be traveled around the conductor. So to to avoid this kind of a situation, the accessories for the arc protection is also available, and that can be used according to the utility uh, experience over the line. Then all these things are available. Additional to this test, we have conducted a lot of tests in our factory because we already have our factories NABL accredited. And we keep on doing a lot of innovative searching and see the results on the covered conductors. So you can see that how the insulation thickness and your leakage current we can measure on the different voltages. 11 kV, 22 kV, 33 kV. We also do some testings to energize the 12 kV system with the tree contacts and other things. Well, what happened when we do that? No arcing, no damages to the conductor, no damage to the tree branches. So this is one of the positive end of this technology. We also do the testing stimulated conditions, like we keep both the conductor together and test it for 80-minute testing, no arcing, no damages to the conductors while keeping them together. Then stimulating with the animals also, whether they can able to bite it or not. There's no bites, nothing. So XLP is a hard material; they cannot able to cut the surface over it. So what a lab should have, any manufacturer should have the lab which can provide all the tests as per the EN standards, and that should have a HV test setup, then the chemical testing setups, then the most important track resistance test setups, then resistivity tests, hot ones there, xenon weathering test chambers should be there, tensile testing, CR meters, then spark test, carbon black test, and then the addition slippage test. All fixtures for the slippage test should be there, because while you are doing the triple extrusion of the cable, the slippage test will give you that the conductor will not come out or slip out from the insulation part. So those tests are very important. These are already elaborated in the EA standards. So that has to be taken into the consideration thoroughly. So now a little bit talk about my experience relevant to the Indian condition. MVCC, we have only 2 labs here, which are fully equipped to test the in this EN standards. So I have taken it the names at CPRI and ERDA. They have the relevant testing, and you can test the entire thing with them for the MVCC, medium voltage covered conductors. As I told you that in India the pollution levels are very high and it attracts the pollutants to stay over the conductor outer surface, allows the current to track. So in all the grades, we recommend that whether it is 11 kV or it is 22 kV or it is 33 kV, we recommend that it should be anti-track. And since the MVCC is going to stay there in the network for 30 plus years, what we are talking about. So while considering the covered conductor, you should also see that in the future the line loads will be increased. So you should you should choose the conductor in that way that it should take the future load requirements also. Rather than you are going to replace it after for 10-15 years, it should be able to serve you for the 30 to 40 years. So the conductors are available because usually what in the bare side what we are using is the triple AC and ACSR. But since you are using ACSR, when you are using it is only operating temperature is 70 degree and your insulation is 90 degrees centigrade. So there is another mismatch. You are not getting the proper delta also to get the ampacity properly, because as a buffer you also have to keep it the entire network at the 60 degree or 55 degrees. So the ACSR, so these there are the technologies in the conductor which has coming out that the triple AC is known for its ampacity, because when all the strands in the triple AC are of aluminum or aluminum alloy, they can conduct better than the ACSR because the middle strength in the ACSR is of steel. So now the technology of AL59 ACS is there, which can give you the ampacity more than the triple AC, and the strength. ACSR is mainly used for the strength because it's middle, wherever there is a hilly terrain where the line is going, one pole is on the top of the hill and the other pole is there is a lot of load is there, and then you need a steel core to handle this load. So this ACS is the aluminum cladded steel. So aluminum cladded steel means that the steel is there, but the whole surface is cladded by the aluminum, and it will again give a good conductivity to the conductor, and you can get almost 30% higher ampacity in these type of conductors. So while decide on the conductor side, covered conductor side, you should also take into the consideration that this technology is going to stay over there in your network for donkey years, and you need to handle the all the load requirements on the line. Ground clearance also compromised due to the urbanization, improved elevation of the roads, illegal acquirement of the hutments, shops, houses. Several, things are there where you can use these. They are using whatever many times they are using the jugaads. You can say jugaad, or you can say non-standard practices to correct the problem, the lineaments. That is not good. Our experience is that if it is we are prescribing the standards over it, then those accessories should be properly installed and used on the line as per the standards. No shortcuts or bypass should be used on the lines. Then basically we also have seen that this has done a very excellent time wise installation time is also very fast and easy in case of the covered conductors, and we always see that utilities are always are in constant to give you the shutdowns while you are reconducting the line. If there is already they are supplying the network to some distribution line is there with the bare line, and you are reconducting it, then they will not give you the all the clearances very fast, or the shutdown time is very less. So in case of the covered conductor, this reconducting can be very easily done without wasting much of the time. And MVCC is very useful here in the, especially on the networks of 33 kV and the 66 kV in the Indian utilities for the use as a jumpers. Because there is a lot of problem they are facing with the big kites and facing because of the eagles, and they have a big span of wings. So once they just sit down on the line and then they spread their wings to take off from there, and then they come in contact and they die. So when we are using these covered conductors as the jumpers, these fertility is reduced drastically. And wherever you are, we see that 24/7 the reliability to the consumer is there with the help of the covered conductors, and customers are very happy, because once we have changed the line, or we change the that area, those people have come back to us and said that yes, there is no tripping at all, zero tripping from the day you have put the covered conductor over there. And before that, in the whole day, we are experiencing 2-3 trippings. So this is what the effect of the covered conductor, and our experience in the Indian conditions. So you see, we have the experience of putting the covered conductors over the line which is going through the sea. On the high tides, the sea almost come half the poles. The splash of water comes on the line, and line get disrupted. So with the help of the covered conductors, now the lines are smoothly running, and no problem with the sea and ocean side installations over it. Then we have the installations over the coconut groves, where they are experiencing a lot of problem of coconut trees touching the line, so that can also be solved. Experience in the forest areas where there are a lot of death of elephants and other things happening, and once we have put the covered conductor over there, then this is being minimized. In the renewable plants, like the wind farms, in the evacuation side, it has an excellent performance. Over the congested areas, colonies, if you see in India, the conditions sometimes are very bad. Even you can find the distribution pole come out from the drawing room of the people. So this is the one of the classic example, that this pole is coming out from the inside the drawing room of one of the hutment, and people lives are in danger. Once we have put that covered conductor over there, now they are safe, at least. On the 66 kV lines also, because the EN standard says that the standards has been done up to from 6.6 kV to 36 kV. But we have extrapolated the standards and come out with the covered conductors for the 66 kV also, 110 kV also, and 132 kV also. And wherever there is a ROW problem, or there is in some spans there is a lot of problem of trees and other things, then here in India they are using this high voltage, extra high voltage covered conductors. So if you see in India, the market presence of MVCC is very good. Now most of the utilities are accepting the MVCC, and they are now coming out with their own requirement for these covered conductors. We have exported these covered conductors from India to many countries like South America, North America, Africa, and some of the prominent installations In the utilities, we have with the Bascom, this is Bangalore electricity supply. There we have put the covered conductors. This is in the, there's a national park, Kaziranga National Park, which is in the entire Asia, the only rhinos are there. So it is a wildlife sanctuary. So we have put the entire sanctuary with the covered conductors in Assam power distribution. Then in Telangana, in the lot of company, a lot of colonies where the the houses are so near to the line and there are a lot of vegetation around the line. They have used the covered conductors and now they are getting a very reliable power supply in these areas. Earlier it used to be a a lot of power cuts. So again, these are the some of the lines which is in the congested areas within the city areas where the too much populations is there. So the covered conductors we have installed. In Kerala, they've used our 66 kV covered conductors and quite reliable form they are operating it and giving a good results over there. These are the wind farms. There also they are experiencing some with the coconut tree touching. So this is an excellent solution over there. PGVC line.
Manish sir, excuse me, sorry for interrupting. Can you please wrap it up in next 2 to 3 minutes? We're already running out of time, so if you can kindly wrap up your presentation.
Yes.
Thank you. Thank you.
Yes. So I just wanted to give that small example that there are the two lines, two feeders going on, the bare feeders, and one is the agricultural line and one is the rural feeder. So in the agricultural line, the farmers is getting only the electricity for 5 to 6 hours, and for the rural feeder they are getting 24 hours electricity. So what happens is once they are crossing it, they are using the jumpers, connecting it, and then taking the electricity for the this agricultural purpose. So once we have put the covered conductor over there, now this theft has been stopped, and the electricity companies are quite happy with that. So this is all with my presentation, and I am now open for your questions.
Thank you, Manish sir. It was a wonderful and excellent presentation, very detailed. You have covered almost all the aspects of the covered conductor systems. We have received quite a few questions, and I would like to cover as much as possible. So would like to request you to kindly keep the answers brief so we can, cater to the maximum questions possible. There are quite a few questions related to the practical system implementation of the covered conductor system. So we would like to begin with that. The first question is from Bhutan, from Mr. Tenzin. He's asking how many joints are acceptable for 11 kV air bundle conductor overhead covered conductor system with approximate of 7 kilometers distance.
If the line is straightway 7 kilometers, because the one drum length of the covered conductor is of 1 kilometer. So you can use the 6 joints over there. But if there is a turning and other things are there, then accordingly you have to see that where the cutoff points.
Okay. His question is actually they have been experiencing multiple punctures, even if it's not heavily loaded. So if you can throw some light over that, what may be the possible
Punctures
reason?
means on which cable? On the AV cable?
Yes.
Yes, here also the utilities are experiencing the same punctures and other things. And as I have told you, there are any lot of causes that can cause the punctures in the line. It is all because of even the copper taping is not proper. If the outer material is not proper, the PVC or HDP is also not good quality, then also that gets punctured. And many times we have experienced that the earthing, because you have to earth the AB cable, and that earthing points are not properly joined. That also causes the things. The animal bites also get affected the cable.
Okay, okay, thank you. The next question is also from Bhutan, is asking for 33 kV distribution system. They are using the covered conductor system. However, he's saying that they had issues with the slipping of insulation, especially at the river crossings. So how can they address this issue?
Please, can you please repeat it? The slipping.
Yeah, they are experiencing slipping of the insulation in the covered conductor, 33 kV covered conductor system at river crossings.
Yeah, for that I have to see that what is the span length basically, and how they are putting it up over there, because it is in that case it is there in the lines like river crossing. They should put the conductor, take out the insulation and put the conductor with the normal clamps, what they used to do in the this bare line. Then it will not be slipped. If the entire load is on the insulation and the span is high, then the insulation might be giving them the problem. So the solution is that they should use the normal bare clamps and insulate it properly with the 33 kV heat shrink tapes, and that
Okay.
their problem will be solved.
Thank you. Thank you. The next question is how much reduction in width for the right of way can be achieved using covered conductor system compared to the bare conductor?
See, as in India, there is not a clear guidelines right now, but up to you can reduce it up to. We have kept it with the side by side these covered conductors, and there's no effect on the 80-minute testing. But 50 mm distance we can easily maintain. But still, we are waiting for the government guidelines to implement these changes. That is what because it is an insulated body, the EMF effect is definitely less. So ROW, to reduce the ROW is very much possible. That is what right now I can say.
Okay, perfect. Thank you. The next question is why the covering of covered conductors is done using the semiconductor sheath. Is there any other material can be used for this purpose?
The semiconducting sheet is to give a proper conductivity to the conductor, and also to, it gives a protection against the harmful undistributed electrical stresses, which is because of the irregular shape of the conductor. That is why we are using a semiconducting layer over it. Without affecting the conductivity of a conductor. You can uniformly channelize these electrical stresses so that it will not be harmful to the outer sheath. Inner sheath of the, sorry, not the inner sheath of the XLT.
Okay, thank you. The next question is, are there any solutions to avoid or reduce the copper tape burning?
See, in covered conductor, we are not using any copper tapes. It is used in the AB cable. And AB cable, why we are using the copper tapes is because we want to keep it on the zero potential, because all the three conductors are bind together. And if there is any current or the voltage is over the conductor, then they will short within themselves. That is why the copper taping is there to keep the surface at zero potential, and this copper is connected with the earthing.
Okay, thank you. The next question is
To keep the surface, zero potential.
Yeah, perfect. Okay, the other next question is from also Bhutan. They are asking that despite knowing the advantages over bare conductor systems, why the cover conductors have not been widely adopted? Is it due to cost or any other factor?
Sorry,
The question is, despite knowing the known
Can you
advantages.
please, Mr. Tala, can you please repeat because of the bad network? I'm not able to hear that.
Yeah, sure. Can you hear me now?
Yeah.
Okay. So the question is, despite knowing the advantages of the covered conductor system over the bare conductor systems, why has the covered conductors have not been widely adopted? Is it because of the cost, or is there something else?
See, in this part of the continent, it is not being because it's a new technology, and any new technology has a cost. So once it is getting popular, then cost will automatically reduce with the volumes. So now in India, you can see that the cost has been done like the AB cable, HT-AB cable, what we are purchasing here. The covered conductors are come at the same cost. Earlier, it used to be the higher than the HT-AB cables. So once the volume started increasing, then the cost automatically come down. When there is no volumes, then how we can sell the things at the lower cost? So that is the one of the basic things. So once it is becoming, and if any utilities is constantly taking it in the huge quantities, the cost will automatically come down. So a lot of players will be there. Then a lot of competitions is there. So automatically everything will bring the cost down.
Okay. Is it possible for you to share some cost estimates, like in comparison to a bare conductor system, what will be the average covered conductor system will cost?
The cost of the covered conductor in comparison with the bare conductor costing, if I can talk about in Indian context. So suppose the entire line cost of the bare is of around 6 lakhs or 7 lakhs. Then the covered conductor entire line costing, new line, I'm not talking about the reconductoring. The new line will be around 20 to 22 lakhs per kilometer.
Okay. Thank you. So the next question is, I think you have also covered in your slides. Is it possible to put covering on the existing bare conductors and used in medium voltage system?
No, because in the covered conductor technology, we have to do the conductor watertight. If it is not watertight, then the moisture can go inside it. So we have to replace the existing conductor and then put the covering over it. A new conductor with the watertight conductor and the 3 layers over it.
Okay, so one of the question is from Dubai. He's asking that they are changing some part of the system. They're replacing the bare conductors in the system with the covered conductor system. So how they can deal with the different effects like skin effect, proximity, Ferranti, corona? What do they need to take care of in this replacement job?
Once we have seen that the surface voltage, we can test the surface voltage and things because to test the corona effect and all. And corona effect mainly comes because of the the sparking on the joint side of the bare conductors. And here you are going through and through with the insulated system. So the chances of any corona is negligible over here. The only corona type effect you can see it while tracking, if the outer surface is not properly come with the anti-tracking material, then there will be some kind of a humming sound or some sparking you can witness. Otherwise,
Okay.
it is an insulated system. To insulated system, these skin effects cannot be measured.
Okay. Thank you for your wonderful presentation, and thank you for the answering the questions.
Yeah, thank you very much, Tala, for giving me this platform to told you a little bit about this technology, which is now getting very popular. And I hope everybody have understood the things, how that we are growing. And it is a very good thing if it can be adopted throughout the utilities. they will, with less maintenance and less operational cost over it. The
Yeah,
wire
definitely.
conductors.
Definitely.
Yeah.
Thank
Thank you
you.
very much. Thank you.
Thank you. Take care. So, dear audience, our expert speakers for today presented the technical specifications of covered conductor systems, the associated costs and benefits that such systems offer over the conventional bare conductor systems. It was a great knowledge sharing session, and I hope that you all have benefited from this discussion. With this, we have now reached the end of our webinar. Thank you once again for joining us today. Saga Energy Center conducts numerous activities on various aspects related to energy sector and for the betterment of the South Asian people. Please connect us through the digital media channels. Goodbye, take care, and have a very nice weekend ahead. Thank you.